Section 9.1, the ellipse. In this section, we'll graph ellipses centered at the origin, write equation of ellipses in standard form, and graph ellipses not centered at the origin. Before we get started, let's go over some key terminology. Also, I want to mention that the plural word for focus is pronounced different ways. Foci, foci, foci. Now, I'm going to pronounce it as foci because that's the way I learned it. An ellipse is the set of all points P in a plane such that the sum of the distances between P and two distinct fixed points, called the foci, is a constant. To visualize this definition, imagine taking two ends of a string at the foci and using a pencil to trace a curve as it is held tight against the string. The curve, which results, will be an ellipse, since the sum of the distances to the foci, the total length of the string, remains constant. An ellipse can be elongated horizontally or vertically. An ellipse has two axes of symmetry. The major axis is the longer axis of the ellipse, and the minor axis is the shorter axis of the ellipse. The fixed points are called the foci, the plural of focus of the ellipse. The midpoint of the segment connecting the foci is the center of the ellipse. The endpoint of the major axis are called the vertices, plural of vertex, of the ellipse. And the endpoint of the minor axis are called the covertices of the ellipse. The standard form of an equation of the ellipse with the center at the origin and major and minor axes of lengths 2 times a and 2 times b, where a is greater than b and b is greater than 0, is as follows. X squared over a squared plus y squared over b squared equals 1. That's the horizontal major axis with vertices at plus or minus a, 0, and covertices at 0, plus or minus b. The other equation is x squared over b squared plus y squared over a squared equals 1. That is a vertical major axis with vertices at 0, plus or minus a, and covertices at plus or minus b, 0. To determine whether the major axis is horizontal or vertical, simply look at the denominators. If the larger number is under the x squared term, then the major axis is horizontal. Now, if the larger number is under the y squared term, then the major axis is vertical. Okay, last bit of information you need to know before we get started is the foci of the ellipse lie on the major axis, c units from the center, where c squared equals a squared minus b squared, which is equivalent to b squared equals a squared minus c squared. So let's go ahead and get started. We're going to start by graphing an equation of an ellipse centered at the origin. In this example, we're asked to graph the ellipse and locate the foci of the given equation x squared over 4 plus y squared over 25 equals 1. Now, the first thing we need to do is to look at the denominators to determine whether the major axis is horizontal or vertical. If the larger number is under the y squared term, then the major axis is vertical. Now let's find the points for the vertices. Notice the vertices point is 0 plus or minus a. So to find the value of a, all we need to do is look in the denominator to see that a squared equals 25. So to solve this equation, all we have to do is take the square root of both sides, and a is plus or minus 5. So our vertices are located at 0, 5, and 0, negative 5. Now let's find the covertices points, which are plus or minus b, 0. To find the value of b, all we need to do is look under the bottom of the equation to see that b squared equals 4. So our next step to solving this equation is to take the square root of both sides, and b equals plus or minus 2. So our covertices have a point of negative 2, 0, and 2, 0. We now have enough points to graph our ellipse. So let's go ahead and plot these points on the rectangular coordinate system. And here's our graph. Lastly, let's find the foci, which is the value of c. To find that, we'll need to use the formula c squared equals a squared minus b squared. Now, we're also going to use our values that of a and b. Recall that a is 5 and b is 2. So let's go ahead and plug in everything we know so that we can find the value of c. On the right side, we see that we have here 5 squared, which is 25, and then 2 squared is 4. Once we subtract those values, we'll get a value of 21. Lastly, we're going to take the square root of both sides, and c equals plus or minus square root of 21. Now, if we were to look at that on our calculator, that will give us an approximate value of about 4.58. So we have located our foci, which again is located at approximately 4.58, both the plus and the minus. In this example, we're asked to graph the ellipse and locate the foci of the given equation x squared over 36 plus y squared over 9 equals 1. So the first thing we need to do is take a look at the denominators to determine what is the major axis. So looking at the denominator, we see that under the squared term, we have the larger number, which means that the major axis is horizontal. Now let's find the points for the vertices. The vertices are going to be located at plus or minus a, 0. So to find the value of a, if we look on the denominator, we can see that a squared equals 36. So to solve for a, all we need to do is take the square root of both sides, and we can see that a would be plus or minus 6. So our vertices are the points negative 6, 0, and 6, 0. Next, let's find the covertices. The covertices points are located at plus or minus b, 0. So all we need to do is look under the denominator to see that b squared equals 9. To solve for b, take the square root of both sides, and b is plus or minus 3. So our covertices are located at 0, 3, and 0, negative 3. We now have enough points to go ahead and sketch our graph on the rectangular coordinate system. So once we plot these points, our graph will look like so. Lastly, we're going to find the foci points, which is the value of c. So recall, to find c, we're going to use the formula as well as the two values we've already found. So let's go ahead and plug everything in so we can solve for c. We see that 6 squared equals 36 and 3 squared equals 9. Subtract those values and we get 27. Next step is to take the square root of both sides, and c equals plus or minus square root of 27. Now, of course, we can simplify that radical, but we actually want the decimal value more than anything to be able to locate it on the rectangular coordinate system. So you can use your calculator to do that, to give you the approximate decimal value there, and it should be about 5.2. So once we graph that on the rectangular coordinate systems, the foci points will look like so. In this example, we're asked to graph the ellipse and locate the foci of 16x squared plus 9y squared equals 144. Well, if you look at this equation, it is not in the standard form for an ellipse. To be in standard form, it would be in the following form, which if you notice on the right side needs to equal 1. If we take the number there of 144, we can write it as a fraction by writing it over 1. Now, if we multiply that by its reciprocal, in other words, just the flip version of that, which is 1 over 144, what you're going to see happen there is everything is going to cancel out to 1. Remember, when things cancel, they cancel to 1. So in order to get the right side to equal 1, we're going to have to multiply by 1/4. In other words, the reciprocal of that right side. But you know what the rules of equation says. Whatever you do to one side, you must do to the other. So that means if we are going to multiply the right side by 1 over 44, we have to do the same thing to the left side and every member there. So let's go ahead and do that. So once we do that and do our cancellations there, or actually you can cancel now or you can cancel later. Let's suppose I don't do any cancellation and I just leave it the way it is. So the way it is, it would be 16x squared times 1. So I'm going to have 16x squared on top over 144, 9y squared on top over 144. And we already know that all of this canceled out and it just equals 1. So if you did not cancel during the previous process, then you would do your cancellations now. In other words, these fractions need to be reduced. So the first one here, the fraction, you would cancel out the common factor of 16, and for the second one you would cancel out the common factor of 9. Now, as I said before, you could have definitely did it at this point, do your cancellations there, and that would save you a step. But the bottom line, it needs to be simplified. So once I do so, it's going to look like so. And now we finally have our equation in standard form. Next, we want to determine whether the major axis is horizontal or vertical. So looking at the denominator, notice that the larger number is under the y squared term, which means that the major axis is vertical. Okay, so let's find the points of the vertices, and that would be 0 plus or minus a. To find the value of a, looking under the denominators, we see that a squared equals 16. All we have to do is take the square root of each side to see that a is plus or minus 4. So the vertices will be 0, 4, and 0, negative 4. Next, we'll work on finding the covertices, and those points will be plus or minus b, 0. So in looking under the denominator, we see that b squared equals 9. Take the square root of each side, and b will be plus or minus 3. So our co-vertices will be located at -3, 0, and 3, 0. So we now have enough points to sketch the graph of our ellipse. So sketching these points on the rectangular coordinate system is going to look like so. And there you have the graph. Lastly, we want to find the foci points, which is the value of C. So we're going to use the values of A and B as well as the equation to find the value of C. So let's go ahead and plug in what we know so that we can find the value of C. So we have 4 squared, which is 16, and 3 squared is 9. Subtract those values and we get 7. Take the square root of 7 and C will equal plus or minus square root of 7. You can take your calculators out to find the approximate decimal value for the square root of 7. And you'll see that the foci points will be approximately 2.6. And of course, that is going to be both the plus and the minus of that. And there you have it. Writing the equation of an ellipse in standard form. In this example, we're asked to find the standard form of the equation of the ellipse and give the location of its foci. So looking at the graph itself, you can see that it is elongated vertically, which means that the major axis is vertical, and the value under the y squared will be the larger number. So our equation is going to look like so. Now to find the value of A on the major axis, if we count from the center to the endpoints, it's about 9 units in each direction, up and down. So twice at will be 9 squared, which is 81. So A squared is 81. And for B, the minor, the distance from the center to the endpoints is 5 in both directions. So when we square that, we get 25. So once we put everything together, our equation is going to be as follows: x squared over 25 plus y squared over 81 equals 1. And there you have it, the standard form of this particular ellipse. Now let's find the foci points, which is C. So we're going to use the equation as well as the values we already know. So recall that A squared is 81 and B squared is 25. We can just plug them already in. We don't need to take the square root of it. We know that yes, A is 9 and yes, B is 5. But into the formula, notice it's A squared. So let's just go ahead and put 81 there and save ourselves some time, and go ahead and put 25 there for B. So once we subtract those two values, we get 56. Take the square root of each side, and it's going to be C equals a plus or minus square root of 56. And again, you could use your calculators to find the approximate decimal value, which should be 7.5 or 7.5 there. And there's our foci points, both the negative and the positive. In this example, we're asked to find the standard form of an equation of an ellipse with a foci at -2, 0, and 2, 0, and vertices at -3, 0, and 3, 0. So first of all, we want to determine whether the major axis is horizontal or vertical. If we look at our foci and notice that our foci is at -2 and 2, both being on the x-axis, and that tells us that the major axis is horizontal. So we can expect once we write our equation in standard form to look something similar to the equation you see here. We're going to begin by finding the value of A. And A are your vertices or your endpoints. And if our foci is on the x-axis, then our endpoints, our vertices, would be -3 and 3. So that means that A would be 3. If we plug that into our equation, 3 squared is 9. So we have that part of our equation. The only thing left now is just to find the value of b squared underneath, and we have our equation in standard form. So again, we need to find b here, and notice, just like the Pythagorean theorem, you need to know at least two values in order to find the third value. So we know a, we don't know b, but do we know c? Yes, we do, because C is your foci, which was given to us, -2 and 2, which means C is 2. So since we know at least two values, we can now use the formula to plug in to find the value of B. And we'll have our equation, because that's what we're looking for. So when we look at the equation there, we actually want to solve for b squared. So let's isolate b, and to do that, I would need to add b squared to each side and then subtract c squared from each side. So now that we have the equation arranged properly so that we can find the value of b squared, let's go ahead and plug in our known values for a and c. So we get 3 squared, which is 9, 2 squared, which is 4. And once we subtract that, we see that b squared is 5. Now we do not need to solve for b, because notice that under the formula it is b squared. So once we place the 5 underneath there, we have the equation now in standard form for this ellipse. So now we're going to look at graphing an equation of an ellipse that's not centered at the origin. So here are some quick facts, or a summary of facts rather, of some things you'll need to know about horizontal and vertical ellipses with center not at the origin. In this example, we're asked to graph the ellipse and locate the foci of the given equation of x plus 1 quantity squared over 9 plus y minus 2 quantity squared over 4 equals 1. Now the first thing we're going to do here is to locate the center. Notice this equation of an ellipse looks very similar, at least the top part of it, to the equation of a circle. And recall, when you wanted to find the center of a circle, it was sort of kind of opposite of what it seemed. For example, here you have x plus 1, so that it meant that your x value would be -1. And here you have y minus 2, which means that your y value would be +2. So our center is located at -1, 2. Next, we want to determine whether the major axis is horizontal or vertical. Well, notice that the larger number is under the squared term, and recall, when the larger number is under the squared term, that the major axis is horizontal. Lastly, we want to locate the vertices so that we can graph the ellipse, but we need to be able to know what A and B are in order to find the endpoints there. So if we look at our given equation here and the model, a squared equals 9. So that means that A would be plus or minus 3 once you take the square root. Let's find out what B is. So looking again at the model, B is here to the right underneath. So B squared equals 4. Once we take the square root of each side, we would see that B would be plus or minus 2. And so now we're going to take these values and plug them into the formulas so that we can find the endpoints or the vertices in order to graph the circle or the ellipse, sorry. Okay, so the first thing we're going to do is find the endpoints or the vertices for the major axis. To find that, all you're going to do is combine the value for A with your X value. So my X value is -1. So I'm going to combine with that -1 a plus 3 and a minus 3. So in other words, I'll have -1 plus 3 and then -1 minus 3. Those will be my two new X values. Now your Y values will remain the same. For my center, my Y value is 2. When we're done, the Y values will still be 2. Remember, to find the vertices for the major axis, you're going to combine A's value with the X value. So once we do that, for the first new X value will be 2. For the other one, our new X value will be -4. So our vertices on the major axis would be 2, 2, and -4, 2. Now to find the opposite endpoint, the vertices or endpoints of the minor axes, the co-vertices, you're going to, for your Y value this time, you're going to combine with it B's value. So you're not going to do anything to your X values. They will remain the same. So our X value, again, for our center is -1. When we're done finding the co-vertices, it's still going to be -1. Now our Y values, on the other hand, we are going to combine with that B's values. So if our Y value is 2 and B is plus or minus 2, so it'll be 2 plus 2 and then 2 minus 2. So once we plug that in, our new Y value for the first one will be 4. For the other one, our Y value would be 0. So putting it together, the endpoints for the minor axis would be -1, 4, and -1, 0. Okay, so we have enough points now where we should be able to see the sketch of our graph. Once we plot those points on the rectangular coordinate system, it's going to look like so. And actually all this was a graph that was originally on the point of origin, but was moved over 1 unit to the left and 2 units, 1, 2, up. And there you have it, the graph of an ellipse not centered at the origin. Lastly, we want to locate the foci. Remember, that's the value of C. And we're going to add that to the X value of our center. We're not going to do anything to our Y value. But the first thing we need to do, though, is go ahead and find out what C is. So let's go ahead and plug it into that formula. Since we already know A and B, once we plug those values in, we're going to have 9 squared minus 4, which is going to give us, when you take the square root of each side, is C is going to be plus or minus square root of 5. So now all we need to do is just simply add that to our x value. So you'll have -1 plus square root of 5, and then -1 minus square root of 5. And recall our y values will stay the same. So these are the points for our foci. In this example, we're asked to find the standard form of an equation of an ellipse and give the location of its foci. So if you look at this particular graph, notice that it is elongated along the y, which means that this is going to be a vertical major axis. And the other thing we know is that when you write it in standard form, that underneath the y squared term is where you're going to have the larger number. So again, because it's longer in the y direction, the major axis is vertical, and we also know that when we write it in that form, under the y squared term is where you're going to have the greater number. Now notice this particular ellipsis, they gave us the center. The center was located at 2, 0. So now to find the equation here, all we need to do is find the values of a and b. And so a would be, recall, if it's elongated this way, that would be the distance from the center to the vertices, which is 1, 2, 3, and on both sides. So 3 squared is 9. So a squared equals 9. And b would be the other way, where the minor axis is, and that's from the center 1, 2, 2 on each side. 2 squared is 4. So once we put all that together, including where our center is located, so if our center x value is 2, when we write it, recall we write it as x minus 2, and when any value is 0, you just write the variable itself with no number there. And so there is the equation there in standard form of an ellipse where the center is not at the point of origin. Hang in there, we're almost done. Now all we have to do is find the foci, which is the c value. So you know, we already know a and b. To find c, we can go ahead and plug that into that formula and find the value of c. So once we do that, we have 9 squared, 3 squared, which is 9, 2 squared, which is 4. 9 take away 4 is 5. Take the square root of both sides, and we can see that c will be plus or minus square root of 5. So once we put all that together with our foci, because this was not at the center of origin, it was at 2, 0, our center. It wasn't at the point of origin, rather. It was at 2, 0, which means that we're going to add that c value, that plus or minus square root of 5, to our y value. Okay? And our y value, recall, is 0. So when you add that to that, you're going to have just the same, which is the positive and the negative square root of 5. So when you put it all together, our foci is 2 square root of 5 and then 2 negative square root of 5. Congratulations! You have just finished learning the course content for Precalculus Math 1140.